Hey guys, welcome back to Math from My Desk, and in today's video we'll be covering the first question of the 2025 AP Calculus AB and BC free response section. By the way, if you hear my voice sound a little weird, it is because I am currently sick. I have a cold. Alright, so let's start. So we have an invasive species of a plant that appears in a fruit grove at time t equals 0 and begins to spread. The function c, defined by c of t equals 7.6 arctan of 0.2t, models the number of acres in the fruit grove affected by the species t weeks after the species appears, and it can be shown that c prime of t, so the derivative of c, is equal to 38 over 25 plus t squared. So for part A, we need to find the average number of acres affected by the invasive species from time t equals 0 to time t is equal to 4 weeks. So this is simply going to have to use the average function formula, which tells you that for a function f of x, the average value of the function will be the integral from a to b of f of x dx over b minus a. So this is the formula. So if we go ahead and apply this specifically to this problem, what you end up with is the integral from, in our case, we're going from 0 to 4. So from 0 to 4 of c of t with respect to t divided by 4 minus 0, which is just 4. And what you have to do is you go ahead and plug this into your calculator. So remember, this is a calculator active question, and you will get approximately 2.778 acres. And this is it for part A. Alright, so now for part B, we want to find the time t, where the instantaneous rate of change of c, so the instantaneous rate of change of c is c prime of t, is equal to the average rate of change of c over the interval time, over the time interval 0 is less than or equal to t is less than or equal to 4. So what we need for this is we want the instantaneous rate of change of c, so which is c prime of t, to equal to the average rate of change of c over this interval from 0 to 4. So that will be c of 4 minus c of 0 divided by 4 minus 0. And so what you do is you go ahead and find what this is. You let c prime of t is equal to this. So what you're going to do is you're going to graph c prime of t and just see when it equals to c of 4 minus c of 0 over 4 minus 0. And in your calculator, you should obtain t is equal to 2.154 weeks. All right, now part C. Assume that the invasive species continues to spread according to the given model for all times t is greater than 0, where the limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. So what we need is we need to evaluate the limit as t approaches infinity. And since here we're doing the rate of change of c, not c, as you can see here, we're going to take the limit as t goes to infinity of c prime of t. And c prime of t is 38 over 25 plus t squared. You could use a calculator to see this graphically, but you can easily tell the denominator is going to grow infinitely big as t goes to infinity, and you end up with this limit equaling 0. So this is all you have to do for part C. All right, so now part D. At time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a defined by a of t is equal to c of t minus the integral from 4 to t of 0.1 times the natural log of x dx. This function models the number of acres affected by the species over the time interval 4 is less than or equal to t is less than or equal to 36. At what time t for 4 is less than or equal to t is less than or equal to 36 does a attain its maximum value? Justify your answer. So what we want to do here first we want to find the max of the function a being defined by this right here. So what we need to do is we need to be able to find our critical points. So we want to find when a prime of t is equal to 0. A prime of t will be continuous on this interval from 4 to 36. So a prime of t, we know a of t is equal to c of t minus the integral from 4 to t of 0.1 times the natural log of x dx. If you were to put this on your calculator, or you could do this manually, it's pretty easy. You end up with a prime of t is equal to c prime of t minus 0.1 ln of t. And so when you go ahead and plug this into your calculator, what you will end up with is that t actually is equal to 11.442. So this ends up being our only critical point on this interval from 4 to 36. And what you can do is you then build a table of values. So you have t and a of t. So you have t, the endpoints are 4 and 36, and our critical point is 11.44. So, and you go ahead and plug this into your calculator, you get that at t equals 4, a is 5.128. At t equals 11.44, t is a of t is 7.317. And then at 36, you have 1.743. So here, candidates for extrema are going to be the critical points being 11.44 and the endpoints 4 and 36. And we can clearly see that 11.44 has the biggest value. Therefore, at time t equals 11.442, that is when a attains its maximum value. So this is how you would solve this problem. So thank you guys for tuning in, and don't forget to watch the next video, which is going to be on question 2 for AB, and then another one for question 2 for BC. So thank you guys for watching. Please like and subscribe, and I'll see you soon.